Push forward. Any questions or anything you want me to review about the midterm? Remember, the midterm is on Friday. Anything you want me to go over? Review, blah, blah, blah.
Do you have an example like question you could just ask us so we know the format in which you ask questions?
I gave you an example last time. Well, I mean, there isn't like a set format. There won't be true, false, or fill in the blank. So all the questions are going to be like, if it's a, what kind of language is Python? Then the expected response would be something like it's a high level, general purpose, loosely typed, interpreted, object-oriented programming language. It's that kind of thing. So, your answer to each thing is going to be like a sentence or two. You won't have to come up with the one magical word that fills in some blank. I won't have A, B, C, D where 3 of them sound like the same answer. So there shouldn't be like tricks. And then there'll be a couple of questions, like I mentioned last time, that I'll give you some code and say, what does this do? And you'll have to explain to me what the and so that maybe the hint I'll give you with that is I want not even the hint, the directive I'll get you related to that is I want to know what the chunk of code does as a whole, not explaining to me what each individual line accomplishes, which is fine. I mean, being able to read each individual line is important, but then decide what all those things go together. Like for instance, if I give you the instructions for making a peanut butter and jelly, I don't want you to say, well, you took one piece of bread out of the bag, then you took another piece of bread out of the bag. You put jelly on one of the pieces of bread. You put peanut butter in the other piece of bread, and that's your answer. Now, the answer is you made a peanut butter and jelly. That's what the code does. It makes a peanut butter and jelly. Does that make sense? So connect the final dots. Here's all the stuff that you did along the way. Ultimately, this is what the code does. Make sense? All right, so shouldn't be any trick questions. If during the exam you're not sure what I'm asking, don't guess. Come up and ask me, and I'll try to clarify or give you a push in the right direction or something like that. Okay, so let's see. And I assume everybody has signed up for the hackathon? If you haven't, sign up for the hackathon. All right, let's open. Where did we last leave off in the book? What class is this? 200? I should give you the 450 exam on Friday.
That'll be interesting.
That's all the same crap. One class isn't really that much. Well, 470 is harder than the rest of the classes. The class will make you cry.
What is 470?
Programming language theory. We write a programming language.
Oh, really?
Yeah. I mean, why use an existing programming language? We can just write your own and use that. Huh? Yeah, CSC 470.
So, like, let's say next semester, I know, like, let's say the whole thing says what classes you should take, right, for each semester.
Yeah, but 470 is a senior class.
Right.
You take that as, either your junior or your senior year, depending on, because it's only offered every 2 years.
Yeah.
So depending on where it is in the rotation during your 4 years, you'll either take it as a junior or you'll take it as a senior.
Right. And when you're like, what did you say would be a good one to take besides, like, what, the 250?
Well, I mean, if you're in this class, you got to take 250.
Right.
So, you'll take that anyways.
Well, with 250.
Yeah, so then you got to look at some of the, you would look at computer science electives. Because the next required course in computer science is 370, which you typically take alongside 300.
Right.
So 370 is being offered this semester. So the 300 is the, you take 200, 250, 300. That's the programming sequence. So you would usually take 370 alongside 300, so you would have that next spring, a year from now. So what you would want to look at, if you're looking at taking some other computer science classes alongside 250, you'd want to look at computer science electives. So I don't know what is offered next semester. I would recommend like the security class, artificial intelligence. It's a really good class. And not enough people take AI. I mean, it's going to be the future of technology. So VR and AI. 20 years from now, you'll live your entire life in VR interacting with artificial intelligence. That will be your life. So it would behoove you to become experts in those things right now. I mean, it's sad, but it's probably not far from the truth. Yeah, I'm looking forward to it. Way less back pain, and the knee pain will go away.
What happens if there is a blackout or a power failure?
Oh, we won't have those.
We're all dead.
There's actually a book I'm reading right now. I just went to fix my glasses. I thought I got out of that habit. Because you've only ever seen me with contacts, right? Yeah, I only started wearing contacts this like a year ago. I've worn trifocals for 40 years. So yeah, a couple weeks. So it took me a while to get used to not like pushing my glasses up when I got in a car or something. But I'm reading a book right now. It's a trilogy series called Alpha World. I'm on the second book. It's pretty good so far. Although there was I'll have to omit some parts from this, but I was just on this road trip with my parents over break. We went down. I took them down to Hot Springs Village, Arkansas, to check out a retirement community down there. So I listened to my audiobook in the car. So I've been listening to this book. It's most of the books I listen to are like sci-fi or things like that. So the premise of this book is there's this guy who's like he's a former security guard or something, or former like prison guard, and he's in jail for the rest of his life because he killed the guy who like raped his daughter or something, so kind of understandable, but still broke the law. But anyways, this video game company has just come out with they're testing these pods to do full immersion virtual reality. So for like a video game that came out where like normal people go in and play for 2 or 3 hours in VR, well, this guy basically lives in the world for months at a time. It doesn't come out, so he's like their guinea pig. Well, that's the whole thing. He's like being medically, he's being monitored and things like that. He's the test case. So it's kind of an interesting book, but there was a bug in the game, so they had to bring the system down for a day. But in game, it was like 2 weeks. Well, he had made all these relationships with like NPCs in the game. It's like he had a relation, like a wife and stuff. So like, I'll be back in 2 weeks. They called them two souls. So the people that are in the game, that are actual humans, are two souls because they have one soul in the game and then they exist in some other world. So that was kind of interesting, effectively like a power outage, right? The server went down and all these people inside the game are like waiting for you to return or something like that. And it was kind of an interesting thing. But the funny thing that happened during the trip was there was a scene or a part of the book that got a little bit adult that I wasn't anticipating. So I have my mom in the back seat, my dad sitting next to me, and my wife was sleeping. Actually, everybody else was sleeping, so I don't think anybody noticed, but I turned it off pretty quickly. It's the Alpha World series. It's 3 books. I forget what the name of the first one is, but yeah, but that was pretty funny. They just can't write books these days that are just sci-fi. They got to throw other things in there. I guess it's what sells. All right, so let's see. We've done branching, we've done loops, we've done functions, we've done strings. We've done lists and dictionaries, but we haven't necessarily like jumped into details of lists and dictionaries, like splitting them apart and things like that, right? We've kind of like sorted. Yeah. We sorted a list. I think we did an insertion sort. Can we do that with the follower variable? Does that sound familiar with? Did we do an insertion sort? Did we sort stuff? What did we do? I was on break too. I don't remember. Have we filled up a list with random numbers and then sorted it?
No, I don't think so.
Okay, let's do that.
Okay.
We have done things with lists, though. We've filled lists with something before, haven't we?
Yeah, I think we did a little bit of that with.
And then searched for
with binary conversion stuff.
Okay.
Maybe.
All right, fine. So let's look at lists as if it's the first time we're seeing it. All right, so way we define a list is with these little square bracket delete flippy things. So I'm gonna actually go ahead and pop open Atom here so we can write some stuff. Let's just gut all this. All right, so I might create a list, and I'll start it off as the empty list. So that's a list with nothing in it. This is similar. We can think of this as a similar problem-solving technique as a string that's empty. All right, so that's the empty string. This is the empty list. An empty list we can build things onto. Now, strings, we would say, is that the comment? What's the comment in this?
Pound sign.
Oh, pound. So strings are read-only. That is, we can't change a string. Let's add this to the slides just so we have a slide for this guy. And I'll put it before our toolbox. Let me look at our toolbox real quick. Got that stuff. Got that stuff. Okay, so we've done mostly string stuff, and then we've just kind of seen lists. All right. So let's do lists versus strings. All right, so with this in mind, since we haven't done a lot with lists, there won't be anything specific to lists on the exam. I thought we had done a little bit more with them. So lists are read and write. We can add stuff to or remove stuff from a list. Strings are read-only. That is, we can add stuff to a string, but can't remove. All right, so what I mean by this, and we've seen some examples. Did we do like a remove vowels or something like that? Had you write like a function to remove some elements from a string? Let's write that. So let's say we have a function. So I'll define a function called remove vowels. And this guy is going to take a string as a parameter. All right. So for example, if I gave it the string HELLO, this guy should get rid of the E and the O. So it should produce an HLL. Does that make sense? So I'm manipulating strings here, but because strings are read-only, that is, S holds some value. So this is the example. If S was equal to hello, our function here should spit out HLL, which is hello with all the vowels removed, right? So our vowels are A, E, I, O, U. All right, those are what our vowels are. So if we're taking in a string and we want to remove vowels, because we have this limitation of strings where they are read-only, so we can only add stuff to a string, we can add stuff through concatenation, but we can't remove things from a string. We kind of have to change that question in our mind a little bit and think about it from the perspective of not removing vowels, but keeping non-vowels. All right, so we need to be able to identify whether something is a vowel or not. Let me go look at our toolbox here real quick. What do we got in here? Okay, so we have this str.find. So this guy lets us find a particular string inside of, well, a particular thing we're searching for inside of a string. So we added this to our toolbox last time, or a couple classes ago, whenever it was, just to review that real quick. I'm just going to cut this for a second. If I say, let's just go ahead and put hello inside of S. If I print out str.find, I'm going to look inside the string S for an H, something like that. This program is going to return a 0. The first location of H in S is at bucket 0. Remember, strings are indexed from bucket 0, so this is 0, 1, 2, 3, 4. So an H will be found at bucket 0. So this guy right here will boil down to an integer, which is the location within S where this character is first found. or it returns, and this is really an important thing, it returns a -1 if it's not found. That's actually a very powerful piece of that. We're going to use it here in a second. It'll return a -1 if the thing it's searching for is not found. So for instance, if I'm looking for a Z is not found inside of S. So str.find will return a -1, letting me know it's not in there. Okay, so I'll go ahead and have it do the H. We should see a 0 print out. Is this on my desktop? Where's it in downloads? Yep, that's it. So there's my 0. That's the first location of H in the string hello. All right. Now, if I do an E, the first place it finds an E should be at bucket 1. There's 1. If I do an L, even though there's 2 L's, the first place it's going to find an L is at bucket 2, not bucket 3. So this will return a 2, the first place it finds it. And O will be bucket 4. And as I said before, if I put in like a Z, something that's not in the string, it'll give me a -1. That make sense? So remember that tool now? Okay. So when I'm asked to do something like remove vowels, so this guy takes in a string S and returns a new string with all vowels removed. That's what this function is going to do. So for example, if S was equal to the string hello, we should spit out HLL. Okay? So rather than thinking about it as removing things from a string, which is not possible because strings are read-only. We can't change the contents of a string. We can only add to it. Rather than removing something from the string, we're going to go through our string, building a new string, and only keeping things that meet our criteria. That is, things that are non-vowels, things that are not found in A, E, I, O, U. Okay? So what I'm going to do here is I'm going to create a variable called vowels. And I'm going to fill it up with all my vowels, upper and lowercase. And then I'm going to have another string called answer. This is the guy I'm going to build my answer in. All right, so as I go through, for example, hello, I'm going to say, is that guy a vowel? He's not, so I'll tack it on to answer. Then I'll say, is this guy a vowel? He is. Skip it. Is this guy a vowel? No. Tack it on to answer. Is this guy a vowel? No. Tack it on to answer. Is this guy a vowel? Yes, so skip it. Now I'm out of things in my string. All right, so I'm going to have to go through every element of my string S. How do I go through every element of a string? Forget about the big problem we're solving here. We're going to solve this little tiny piece. I need some sort of structure that will allow me to go through each element of a string. Do a loop. So we'll do a for loop. All right, what's this for loop going to look like? What's my kind of my stock pattern for for loop that takes I on a voyage through all the indexes of a string S?
For I in range. As X.
What's the first? I want I to be in a range between two values. What's the very first value you want I to be?
The length of S plus 1.
That's if we're going in reverse.
Oh, so it's S comma S.
Range is going to be numbers. So if I have a string hello, I want to go from 0 to 4, right? So my range is going to start at 0, and I want to go to, but not including, the number of characters in S. How many characters are in S?
Length of S.
length of S. That guy. And if we really wanted to include the last variable for range, the default is 1. We can say step by 1. That would say go from 0 to 1, plus 1 is 2, plus 1 is 3, plus 1 is 4. But that's the default step size if we don't put anything there. So this is saying start I off at 0, keep going until I is less than, as long as I is less than the length of S, however long S is. In our example here, S will be 5, but S could be whatever. So this is going to take I on a voyage. And I'm going to go ahead and I'm just going to print out I in here showing this. All right, so the first time through I will be 0, then it'll be 1, then it'll be 2, then it'll be 3, then it'll be 4. I'm going to go ahead and call my remove vals. And I'll pass this guy hello. Get rid of this stuff up here for right now. All right, so here's my function. What's a function again? What would be the definition of a function? If somebody were to ask you one on an exam. Doesn't have to be a, some sort of memorized, this isn't one of our chants. Just generally speaking, what's a function? If you were to describe a function to me in your own words, what would you say?
It does something to something else.
Does something to something else. That's pretty vague.
It is.
Let's get less vague. What do you think?
Reusable and used multiple times.
All right, so kind of a reusable chunk of code. So here's a chunk of code, right? So I've created a chunk of code here. I gave this guy a name. He takes some 0 or more parameters. I write it once and I can use it multiple times. Because I want to be able, I have this tool now that I can pass any string to, and it will, in the end, it will remove all the vowels. Right now, it's just going to count the number of, count through the buckets of the string. All right, so it's a reusable chunk of code that we write once and can call multiple times. So here's my chunk of code. If I never call it, this code will do nothing. Because this guy is the definition of a function. I've never actually called upon that ability. Okay? Just like all of you came to class today and you probably knew how to subtract 3 from your age. But that would be a weird thing for me to ask you to do in class. So it's an untapped ability that I haven't called upon yet. All of you have that ability written in your head somewhere, right? So you got that function, I just haven't called upon it. All right, well now we're going to go ahead and we're going to call upon our remove vowels function. So notice this guy is not indented inside of this, so it is separate, part of the let's call it main program for right now, just because this is what all our Python programs look like for now. They'll change a little bit in the future. So I'm going to call remove vowels. I'm going to be passing hello in for S. So for this particular call through remove vowels, S will be equal to hello. And this guy should create vowels, A through A, E, I, O, U. It should have a string for our answer that we never use. And it should just go through from 0 to the length of S minus 1, printing out I each time. So it should print out a 0, then a 1, then a 2, then a 3, then a 4. So there's our 0, 1, 2, 3, 4. If I pass this guy elephant, instead of hello, it should pass in 0 through 7, or print out 0 through 7. So all I changed was the parameter I passed in, and now it got the length of S this time, when the length of elephant is 8. Make sense? Isn't it impressive how quickly I counted the number of letters in elephant? That's the example I always use. I only know the length of those 2 words. Every other one I gotta count.
Gotcha.
Sometimes it's this long word I gotta use audience members.
Okay.
I gotta keep track. What's this?
You could start, you could have one person do the ones call.
Oh yeah, we can each represent a letter.
Yeah.
We'll have to do that for our sorting algorithms. It'll have to be a group exercise. People will be flip-flopping. Oh, we'll do that.
Good.
Man, merge sort's gonna get crazy though, because you'll actually have to duplicate yourself. No, I'm sure we have 2 or 3 people in here who can duplicate themselves. Probably the same people who passed the Mendix certification. I'm just saying. What's up?
Isn't the one who passed dropped the class?
I don't think so. I think there's 3 people that passed. In here.
Yeah, I thought it was 2.
Might have been 2. I think when I graded it, I remember seeing 3 that passed.
Well, Blaine and I were like, 1 question.
Yeah, I remember you guys failing.
Yeah.
I distinctly remember the failure.
I think about it.
Yeah, it said it didn't. You did not pass. It's what it said.
Like, sorry, it did not pass.
Yeah, I really like the bold font.
You did not
All right, so do we understand that's what this for loop is doing right now? It's just taking I on a voyage between this number and this number minus 1. Now, I'm not actually using those numbers yet. I'm just counting at this point. But we can see that we can call this function multiple times, and it counts a different number of times depending on the length of the string I pass in. All right, but now what I want to do is I want to, instead of just printing out my numbers, which isn't really what remove vowels should do, I want to identify whether or not a particular character I'm looking at is a vowel or not. So let's modify this a little bit, take it one little step at a time, and this is the approach you're going to want to take whenever you're writing programs, especially on the exam, but homework as well. Because we've had a couple of programming assignments now, and you've seen that these things take longer than you would hope they would take, especially when you come to class and you see them solved very quickly, right? Part of that is because you're still practicing, but it's also because your current approach to solving problems is trying to solve the big problem, instead of solving a tiny problem followed by another tiny problem followed by another tiny problem. So you need to get a skill in breaking problems down to tiny pieces. So right now, we have now convinced ourselves that we can take I on a voyage through all the indexes of our string. Now let's take this one little step further, and instead of printing out the value of I, let's print out the value of our string at position I. All right, so we'll say S at position I. So now this should print out E, L, E, P, H, A, N, T. All right, so now I am using the value of I. I happen to take I on a voyage from 0 to the length of the string minus 1, and I happen to be using that value to extract a particular character from my string S, whatever S was. All right, and similarly, if I change this back to hello and change nothing else in my logic, now it'll print out HELLO. Make sense? All right, so these are kind of the little, little exercises that we can do, kind of getting towards ourselves. Now, the next thing we want to do is we only want to print out things that are non-vowels. We'll ultimately concatenate on this, but for right now, let's just print them out. So for hello, we want it to print out H, then an L, then an L. So we need to ask ourselves, how do I determine if a particular character, for instance, if S at bucket I, is a vowel or not? All right, so I'm going to start off by I'm going to say str.find. We're going to be looking in vowels for S at bucket I. So I'm not asking you a question yet. I'm just going to print out some numbers. So as I go through here, it should give me a, it should give me a -1 for an H. It should give me a 1 for an E. It should give me a -1 for an L, a -1 for an L, and it should give me a 0, 1, 2, 3, a 3 for an L. Right, because I am searching inside the string vowels, this guy right here, for each of my characters in S. And it's going to tell me where it found those. All right, so as I look at that, we notice that any time we see a -1, we're looking at a non-vowel. We're looking at something that was not found in my string of vowels. Correct? So now I have a little litmus test. Okay, to determine, I can dip a character in, and when I come out, if it looks like a -1, it's not a val. It was not found in that val string. Does that make sense? So now I want to be able to ask the question. I'm going to say, if when I test, that's what this guy right here is doing. When I search for S at bucket I inside of vals, if I get a value that is equal to -1, that means it was not found in there. Remember a little bit ago I mentioned that str.find gives us a -1 if something was not found, and I mentioned that that's really important. It kind of seems like kind of an extraneous feature, like, oh, who cares? But it's actually maybe one of the most useful features of it. Because sometimes you're looking for the position in a string. We've used that before when we were mapping from like 10 to A, right? Sometimes we're looking for the position, but more often than not, we want to use this to find out whether something is a member of a set. And -1 can give us that answer. So if the current character I'm looking at, when searching inside of vals, gives me a -1, that means it was not found in there. Therefore, it is not a val. We'll go ahead and print that guy out for right now. Okay? So as it goes through, it's going to hit the H first and say, that guy's not found in vals. It gave me a -1. Print it. We're going to get the E. E is found in there, so it's going to give me something else other than -1. So this is going to be false, this Boolean expression. What's a Boolean expression? This is the chant one. If you're going to do the shorthand true-false thing, you got to make it kind of almost like you're doing some sort of magic spell. True or false. So it's any expression that boils down to a single value of true or false. Or we could just say true or false. All right, so that guy, even though it looks like it's doing all sorts of numbery stuff, once we actually resolve it down, that's going to give us a single value of true or false. This guy's going to be a number. Is that number equivalent to that number? True or false? Okay, so for an H, it will be equal to -1, so we'll print out H. For an E, it won't be equal to -1, so we won't do anything. We will skip the body here because this guy will boil down to false. How do we know that this statement is part of the body of this if statement? Because it's indented. Okay. Super, 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 super important in Python, and it's one of the reasons why I like Python as a first programming language. Other programming languages encourage you to indent, but do not require it. Yet, as a human programmer, you should always indent your code so it's readable. Okay? So Python forces you into this habit. You want this guy to be part of this if statement, you have to indent it underneath the if statement. It's a good habit to get into now. Later on, you'll just continue that habit even though it's not required. All right? So this should print out the H. It should skip the E. It should print out the L. It should print out the L, and it should skip the O. At that point, we've now run out of indexes in S, and we'll get to the end of the function here, and we're done. So we should now see H, L, L, which are the components of the string we want to return, but we haven't actually glued our string together yet. So there's H, L, L. Make sense? All right. So last thing is I want to return a new string with all the vowels removed or with all the non-vowels kept. So I'm going to put my answer inside of answer. So rather than printing out S at bucket I, I'm going to say answer is equal to answer plus S at bucket I. And then once this for loop is done, I will return answer. All right. What's this operator right there? The plus sign I have highlighted.
Addition.
Okay. Why isn't it
in this
addition?
case, it's concatenation.
Concatenation. Or catechation, as long as you say it with the mumbling catechation. So, all right, so this the plus operator has two meanings for us, right? It means addition if what is true.
Both sides are integers.
Yeah, if this guy's a number and this guy's a number. Not necessarily integers,
Yeah.
because you can also do doubles, but yeah, so we can just say generically if they're numbers.
Mhm.
All right, so if both sides here are numbers, this guy will be treated as addition. But if both of these guys are string types, he will be treated as concatenation. Concatenation says glue stuff together. So we will glue an H onto the empty string. Then we will glue an L onto the string containing an H. Then we will glue an L onto the string containing an HL. So in the end, we'll return HLL. All right, what will the output of this program be? HLL? Okay, so tell me why you're wrong.
Wait, what you had again? Oh, because the answer is doesn't have a waterman. Oh,
This goes back to don't judge a book by its cover. Here, I'll start out, I'll give you a hint. Answer definitely has the right answer in it.
Mhm.
What do you think?
well, yeah, you aren't printing the function.
Yeah.
You're doing print the function.
This guy right here is going to boil down to a value.
Mhm.
What value will it boil down to? It'll boil down to whatever answer had in it. Because that's what that guy returns. What am I doing with this value?
Nothing.
Nada. I mean, I could store it somewhere, right? I could say blah is equal to that. Now what will the output be?
Nothing.
Still nothing. I'm storing it in blah, but I'm not actually doing anything with that. If I want to actually have output to the screen, I got to print it. Make sense? So now we'll have our HLL. All right, so questions about that? A lot of good stuff we just talked about. That was pretty good review for the midterm because we did a lot of things in there that because this is really a pretty easy program to write.
Mhm.
In the end,
Mhm.
right? You notice how we did it in these little tiny baby steps. Okay. Now I promise you, once you get better, you won't have to do it in little baby steps. But right now, until you get annoyed doing the little tiny baby steps like this, do it like this. Don't immediately jump for the final answer because you're going to trip more often than you'll succeed. And then you'll end up spending 8 hours in an assignment that only takes 5 minutes. Looking for the perfect set of 5 lines, right? And the worst, I've told you multiple times, but I'll say it again, the worst thing you can do as a programmer is the trial and error approach, where you just keep changing stuff in your code until it magically works. And then you think, oh, well, now I can program, and you have no idea why the thing in front of you does what it should do. Okay, you don't even remember what the last thing you changed is, right? I run into this in real life. I broke my back when I was 18. And that's when I got heavy. But so I can keep golfing and stuff, I've surrounded myself with things to keep my back in shape. So I have the adjustable Tempur-Pedic bed, and I have a hot tub, and a massage chair, and an inversion. Who knows which of those things actually was the thing that finally helped? Well, I don't want to give up any of them because something might go wrong, right? But I don't know. Maybe 3 of those things are useless. Just a good thing to spend money on. Who knows? And trial and error is not necessarily the way to do it unless you want to spend a lot of money on crap. So it's an economics lesson as well, I suppose. Okay, so good rule of thumb, never write a line of code unless you've at least given a educated, I don't want to use the word guess, but you put some thought into why you're writing that line. Okay, you're not just trying it to say because nothing else has worked. All right. Now, sometimes you want to test the water. Sometimes you're like, well, I don't really know what this function does, so let me write something and see how it works. So like we did that a few minutes ago with the str.find. We just said, let's print out str.find on our string vowels for each character in the in S. And let's just see what it prints out. And then pretty quickly, the pattern came out that anywhere where there's a -1, we're looking at something that's a non-vowel. So then we were able to use that by looking for negative ones. That makes sense? All right. Similarly, if we want to take this exact same function and I want to do something called remove numbers, I just need to change my vals. Probably should change it to a variable called numbers, but you don't have to. So now as I go through whatever string was passed in, it's going to look for each character inside of numbers, and if it doesn't find it, it'll keep it. So this guy should now remove numbers. So here we'll that's leet speak, right? That's hello. So you can still read that. So this guy should remove all numbers, so we should be left with an H. So there's my H. So identical pattern here, just the list of, or the string, the collection of characters that we're trying to omit, I just changed. Make some sense? All right, so now I'm going to come down here and we're going to create a list. Let me actually show you something else real quick, just because we only have a few minutes left. I wanted to show you a quick little pass by value versus pass by address thing. All right, so we're going to have a change string. A function called change string is going to take an s as a parameter, string. And I'm going to set s equal to LOL. All right, and that's all that guy's going to do. All right, so I'm going to go ahead, I'm going to create a variable called s, set equal to hello. I'm going to print out s. Now notice that this s and this s are different s's. They're in different scopes. So I can name this guy whatever I want. I can name this guy blah, like I had before. Not until I actually pass it to this function will it become called s. All right, so I'll go ahead and I'll print out blah. Then I'm going to call change string, passing it blah. Then I'll print out blah again. All right, so this is a pretty important concept here. So I have a string. I started it off as hello. I'm going to go ahead and print it out here. What should print? Hello. No tricks there, right? We should print out hello. The contents of blah, which is hello. Then I'm going to pass it to change string. So the contents of blah, which is hello, will come in and be referenced as s in here. And I'm changing the value of s to be LOL. That's all I do in there. Then I come back out to here and I print out whatever's currently in blah. What will print out this time? Think LOL? But you're not sure, right?
Or what did they make it sound like?
Yeah.
We got hello and hello.
Mm-hmm.
Strings are passed by value. I gave it a copy of the string blah. So when it changed s to LOL, it was changing my copy of hello to blah, or to LOL. But my original still remained the same. Now, these variable names here aren't as important other than the fact I'm just kind of showing you that I expect this guy to take in a list. Okay, but you could call it, I could have called that guy, H or something like that. All right, and what I'm going to do is I'm going to say list at bucket 0 is equal to 4, something like that. Okay. So then down here, I'm going to go ahead and we'll just do it on the, I'm going to say my list is equal to the list 1, 2, 3. Then I'll go ahead and print out my list. Then I'll call change list on my list. Then I'll print out my list. So my list will start off as the list 1, 2, 3. I'll print it out. We'll see 1, 2, 3. Then I'm passing it to change list, which looks a lot like change string. And what I'm doing is I'm changing the very first element of that list to a 4. Then I'm printing out my list again. Now it should be 4, 2, 3. Notice that it's changed. So what does that mean for us? Lists are passed by reference. Reference. Yeah. Make sense? Okay. So remember, we have the midterm on Friday. We will pick up with lists on Monday. And then we'll get going here pretty quick. We'll do some searching stuff. And then we'll do something fun. All right, I will see everybody on Friday. If you do have any questions ahead of the exam, post them on Slack. Either I'll reply or one of your classmates will reply. It'll be a good way to help other people study as well.